it's about. Welcome, folks. Tonight we're working on the Module 7 lab. If you recall, when we were going through the lecture materials the other night, we did kind of start pseudo-coding this a little bit. We read through the description, and then we started building a skeleton of the code inside of Visual Studio. And we're going to just kind of quickly revisit that stuff. And basically, the point of this is you have some sort of a product, and now you're ready to sell it. And then you're writing a program that displays your products, allows the user to view the descriptions about each product until they choose to exit. And we have certain requirements here that we're expected to do, like building an abstract class with this stuff in it, a class for the product, a driver class to run the program, and then extra credit if you put in input validation, right? And then what we did, if you recall last time, is we got the project started in Visual Studio. So we're just creating a console app with C#. And then I went ahead and I created a product.cs file, right? And this is going to be our blueprint file. We created both the abstract class that they asked for with all the requirements that we're going to add, right? I just basically borrowed from that list in the assignment description. And we'll probably bounce back and forth to that a couple times to make sure we don't miss any data. And then we've built the other class that inherits from product, right? And is a regular class. So this one's an abstract, which means its only purpose is to build other classes, right? That, if you guys recall, that's what an abstract class does. So it'll have certain data fields that Salsa will incorporate. And then we'll build Salsa with an additional data field and these constructors and overrided toString method. Back in the main program, what we did is we just, said, okay, this is the main program. I guess we really don't need that anymore. But we have instructions here for what to do in the main program. Also, that came from the lab instructions. And once again, I have the stuff sitting here as basically a reminder of what to do, right? So I don't have to bounce too much back and forth between that description, but I'm still going to be doing some of it. And so here's where I'd like to start. Like when I'm building a program that involves classes, right? So I'm going to build some classes, maybe inherit some classes, and maybe build an interface or whatever. I usually like to start with those files. I like to build the classes first, because that helps me when I get to running a program. My class structures are built. And if you remember class structures as kind of like custom data objects or data types, those are all built and ready to go. I don't have to futz with them afterwards, right? So every once in a while you forget something and you have to go back and add it. But the hope is that you can build your classes, right, your blueprints, and then you build the objects. So I think the way the program requirements are listed here in the assignment are in a good logical order. In other words, this is how I would proceed, right? Because if I'm going to build a class that inherits from this class, well, I want to build this class first. So having this one at the top makes complete sense, right? So let's build that. And notice here, they're telling us to do this. And so I'm going to borrow these little pieces of information here. And back in Visual Studio, that's going to go to our product.cs file. And that's going to be in the abstract class. When we say the data fields, I'm just going to paste that right here just to remind myself, all right, that I need to do it. And then I'm going to create a little space here, and I'll leave that down below. Maybe I should, let me Control Z that. Maybe I'll put it below that, right? And if you want to keep the comments in, hey, go for it. If you're not doing comments, go for it. That's fine. Whatever floats your boat. My general way of thinking is, and maybe this is a slight byproduct of my age, is, man, if I don't like write something down and make a to-do list, I kind of tend to forget, like, what was I doing? And then that slows you down, right? But if it's hot on your brain, and this is why I did it at the end of the last class, it's hot on my brain that, hey, if we make a to-do list now, it's going to save time on Thursday. Maybe we can get done early on Thursday. Woohoo, right? For sure, right? Or maybe we can get deeper and start talking about the final product or project as well. All right, so here in the abstract class, we're asked to build these data fields. So we have, and we're given the data types. Okay, that makes it easy. So string, double, and string. Okay. Um, question. This is an abstract class. Should these be private or should these be public? You see any reason to privatize them? And Caleb, I see you shaking your head, right? I think everybody else is deeply contemplating that question right now and probably not knowing how to answer it. And generally speaking, in this situation, because an abstract class is only one that we're going to inherit from, right? Public is actually okay, especially if we want to ever change any of the values for any of the things that we're going to build. All right, so let's just go ahead and start building these. And I'm going to use the public keyword. And well, we're going to build the stuff that's on the list there. So I'm going to build a string. Because it's a string, I'll put the question mark after it just in case it's blank, right? So we don't error out. We'll give it a name. The name variable was given with an uppercase, so I'm going with it. And I do want to get in the set, right? I'm going to repeat that process. So we'll do public string, okay, description. I just accepted it because apparently it's looking up here. So I'm just taking it. Why not, right? Okay, not a product ID, but you know what? I can set this one to be called size instead. And notice, what I'm doing is I'm not fighting the IntelliSense. I'm letting it create as much as it can. Why type? Let's be logical about this. If you really want to type it, hey, manually, you go for it, for sure. All right, this one's going to be a number. So we're going to say public. They told us to make it a double, so we're making it a double, and that's going to be the price. Let's do a get and a set with that. And I like what C# does here, or really this is Visual Studio doing it. You put in a variable, and then it throws this little extra line in telling you how many things are referring to this right now. So if you see that this stays at 0 references when you're all done building your software, you can get rid of it because it's not being used. That's pretty helpful little thing. All right. If you want to keep, the thing here, go for it. Now that I've created these, I'm going to get rid of that. I'm just call it data fields or properties, if you will, built into the object. All right. That's the one thing. Now we need a no arg constructor. So let's build that. Right. So a no arg constructor is a constructor that has the exact same name as the class, but no parameters are being passed in. I'm going to, for the most part, make everything public here. I don't see any reason to privatize anything, right? This is just a product list ultimately. So public product, empty parens, curly brackets, and then I'm going to go ahead and split those. And I'm going to do it in the fashion that C# likes, which is like this. If I was doing Java, by the way, in Java, we do it this way, right? In C#, for whatever reason, they do it this way. Both ways work, by the way. All right, so what would a no arg constructor look like? And I don't think there's any special instructions. Two constructors, a no arg and a for arg. Okay, so a for arg one, we'll just take all those data fields and set them, right? A no arg one, that would be like we're building it and we don't know what to put in there. So we got to come up with some defaults is basically what we're doing here. So we'll just take each one of the data fields. Let's do name. And we'll set it, I don't know, what's a good name for a product that we don't know? How about unknown? Or, come up with something. All right. Size, well, I could say unknown again. Last time what I did is I just said size. Yeah, maybe that's not very clear. You got a better name, go for it. Default price. How about free? Well, if we don't have a price, I don't want to type one in. $1 million. Right? a description. Well, this is coming up with unknown. I mean, I guess you could put unknown in everything. And I think what I'm going to do is TBD. Why? Because that's what I did last time. It worked fine. So there's a no arg constructor. It does set all the data fields, builds the object. We might not like these entries, but ultimately we're going to do a for arg constructor that will fix that issue. So one thing that you could do, right, if you want to save a little bit of time, is you could copy this one, paste it in. It won't like it, right? But then we can start to change it. And what we'll do is we'll take all of our data fields from above and just basically include them here with, let's name them the same way, but use a lowercase letter to start as a parameter. So we'll do string question mark name, string question mark size, double price, and string question mark description. Okay. So they're basically the same names. I'm just using upper for the internal and then lowercase for the parameter being passed in. All of this stuff, of course, is going to have to change. So we're going to type the new parameter names in here. Yeah, and it is, it took a little while for the IntelliSense team to catch on there, but yeah, that's appropriate. All right. So there's our no arg constructor and a for arg constructor. A little underline here. Yeah, I'm not worried about that too much because we're not going to let that happen. We do have the question mark in there that will help a little bit too. Okay. Last task is to create an override toString method that's going to display all those fields, right? And this is something that's very easy to concoct. So let's just do that. We're going to do public. Remember, somewhere in the master object class, there's a thing that allows it to be adjusted, right? And here we use the override command, and it is going to return a string, and we will call it toString. All right. And okay, let's. All right. So notice, this is kind of interesting because it did this automatically. Where the heck is it getting this from? Remember when we use the keyword base, that means it's going to the master object class and pulling the toString method that's already there, which defeats the whole purpose of doing this. But it would not break anything, so that's why it automatically dropped in. For us, what we're going to do is we're going to return in the fashion of string interpolation, so $ and double quotes, all the pieces of data that are present. And you can kind of put this in any format you want, but this is what I did last time, right? It doesn't matter how you get the information on the screen, just get the information on the screen. But I did name, the size in parentheses, a comma, the price and formatted as currency, a new line, and then a description of the product. And if you're wondering where that came from, obviously from, here, right? The name, the size, comma, the price. Oh, and I noticed there's a heat level hot that, oh yeah, that's going to be in the other class. And then the description. So that's where that layout came from. You guys all good? Questions or anything so far? All right. That's a good sign. All right. Now, when we built this product file, and I am doing a control S. Yes, Kel.
I do have a question.
Yeah.
I built, I know you said we could do this. I did not use a separate CS file for the other class structures. I just have those at the bottom of my of the code. And so my public product has the red squiggly lines underneath it. But that's okay to do that, correct? I can have those class structures at the bottom of the code.
You can, right? But you have to put it in the right spot. So like if you're going to put it in here in the main program file, it's
Right.
got to sit outside this set of curly brackets. So if you're putting it like here, it won't really read right. It needs to be outside that class. So you would put your two class structures right here. So check your curly
Okay.
bracket structure. And if you're
Yeah.
still getting the red underline, let's throw it up on screen and try to figure it out. I mean, while we're in process of doing it, because even if it's not working for you, I mean, there's a way to make it work.
Right. Okay.
Just let me know where you're at with it, but I'm going to keep rolling forward.
Yeah,
For,
go ahead. Go ahead. I'll play with it
all
here.
right. All right. Let's now turn our attention to this class where we're going to create a class called salsa. It's going to inherit, that's what the colon implies, from the class product, which we happen to have on the same page. But these could be two separate files, or like Caleb's trying to do, put them all in one file. That's fine too, right? So either way is appropriate. What it asks us to do here is to create one additional data field at a minimum. And the one that they demonstrate in the assignment is the heat level. So I'm just going to copy that. There's no reason to kind of create something different. But if you have some other thing that you want to, it does, remember, doesn't, your product doesn't have to be salsa. It could be t-shirts, you know, or, you know, whatever you want to sell. So here I'm going to create the new uh, data field, and I'm going to make this a string, and it was heat level. And so I'm going to name it heat level with capital letters. We'll do the get and the set, and that'll be our one additional setting. We're asked to make a no arg constructor. And you know what? It already started typing it. So I'm pressing tab. Thank you, Visual Studio. I'm just going to accept that. And I'm going to close the curly brackets right away. And then I'm going to split them and arrange them the way C# likes them, which is like this. And then I'm going to move my little comment here, place it there. So, question, right? If we do a no arg constructor, and I don't know if it says any more about that. Okay. Any school appropriate product. Okay. Salsa must inherit from product done, one additional property done, two constructors, and no arg, and a 5 arg or more, right? All right. So if I add a no arg constructor, what data field is it going to set automatically? Well, the one I just created, right? The one that's unique to this class. So I'm just going to put in heat level, and I don't know, maybe, you know, since we're doing salsa, maybe I shouldn't say unknown. Let's just assume it's, you know, not unknown, but let's let the heat level is mild. That way everybody will buy it, even if it's screaming hot, right? You could throw some habaneros in there and mess them all. So that'll be our default heat level if it's not declared. Then we're going to need a 5 or more arg constructor. And here's where we have to be a little bit careful, right? Think about this. If I do a no arg constructor on salsa, it's going to come in here. It's going to set the heat level to mild, but it's also inheriting from the abstract class product. So it's also running the no arg constructor of product. So if I run a salsa constructor, it also adds that stuff with those settings. This is the inheritance piece. It's inheriting from here. So the moment I create salsa, it comes up to product and grabs its data fields using its no arg constructor and building it with these values and mild. Now with the 5 arg constructor, we're basically going to follow the same pattern we did before, right? And what I'm going to do here is I am going to copy this constructor, and then I'm going to go up top and grab all the incoming parameters, right? And you guys remember, we also have to put in this little base keyword with a colon that pushes it up to the, to the base class, or, what we call the parent class or the super class, right? All right, so let's borrow this, right? The heat level, we'll worry about that later. But inside the parameter list here, I'm now going to come up top and I'm going to borrow these because these are the parameters, or some of the parameters we're setting down here. So we're just going to paste those all in. Still got string name, size, double, price, string description, all of that's at play. But then we have one more, right? So we'll put in a comma, and this is going to be a string. Put in your question mark there and do heat level. And actually, once again, I want to name it differently, lowercase h to start, but I will use a capital H here, right? So those are all the parameters, but here's the but on this one. Because some of these are being pushed up to the base class, I'm going to do a colon here, say the keyword base, and then in parentheses, I'm going to indicate which ones belong to the base class or the super class, and that would be name, size, price, and notice it wants me, it's giving me all the code right there. I'm fighting it a little bit. I'm going to actually type it, description, and then finally, no, that is the final one. Okay, so all 4 of those go to the base class, right? Right. So those point up top. But this part, this is kind of an unusual aspect of C#, but it shows the precision nature of the C style programming languages. Like if I was doing this in Python, it never happened. We would never do this in Python. If I'm doing it in Java, they have different syntax, but I don't think it's normal in Java to do this either. My memory serves me right. All right. So I did the no arg. Okay. So I screwed these up, didn't I? All right. I don't panic. I'm just moving the code around. Right. So this is the no arg. And I did my edits on the no arg, which is not what I wanted. So then I'm going to pull this one now and put it here because this is the 5 or more arg constructor. That's more appropriate. Now the heat level, this is going to be coming in as a parameter. So I'm just going to copy this name here and drop it there. So that's an incoming parameter that we're setting externally. One new data field, one no arg constructor, one 5 arg or more constructor with the base class declaration in there. And now we need our override toString method, right? And if you want, you could, I'm just giving you ideas here. You can copy some of this code so you don't have to type it. And then curlies. And then you got to just come up with your return statement and figure out what that's going to be. I do have one that's already built. This is what I built, right? And you do not have to build it the same way. I do want you to notice that I put concatenation in there so I could split it across lines. And the reason I did that is I'm going to put name, size, and price on one line, carriage return, heat level on the next line, carriage return, then description on line number 3. And for whatever reason, right, I could have put that all in one line, one string, right? I don't even need the concatenation marks to do it. But the reason I did it this way is if I do it this way, the way that I lay it out on the screen kind of matches up and it'll be kind of what it looks like coming on the output. That's kind of why I do it. All right. So our classes then are built. We have our super class and our subclass built. I'm doing a control S to save that, right? I don't want to lose my work. All right. And just to kind of review, here is our abstract product class, 4 data fields, a no-arg constructor, and then a 4-arg constructor and a 2-string override. Then we have our subclass salsa, which inherits from product, 1 additional data field for heat level, a no-arg constructor that sets the heat level to a default, and then a 5-arg constructor that ties back to the base class, populating all the fields, and then override 2-string. So that's kind of the synopsis of that one. Let's move over now to the main program file and start looking at how we're going to make the program run. And mind you, right, and I'm going to go back to what I said at the beginning. We started by building the things that we want to use within our program, which is salsa objects, right? And how those are built, whatever, but they're built now. All I have to do is utilize them. And I think that's pretty neat that you can do it like that. Let's read the instructions here. So we're going to populate a list with some specialized products. This could be hard-coded, and that is what I'm going to do, right? Or you could ask somebody to enter them if you really want to do that. And I want you to notice that it's telling you the data structure to use. It says populate a list, right? So we're going to make a list of objects is what we're going to do. And then as we do that, right, we are going to hard code some values in. And this is where like you're going to have to figure out some stuff to type in. I already have a pre-configured list, so I'm going to kind of just like brute force paste it in there, and you guys can work on populating it yourself. And then we need to put a menu on the screen, allow the user to view product data, then probably put them back to the menu and ask them to do it again, and then give them an option to exit, and then ultimately add input validation. And we're going to demonstrate both approaches. And I know the input validation is kind of like extra credit. Now we have, I think, did a little bit of this a few sessions ago, and you guys might not even remember it, but I'm going to revisit the topic and show you how to do that input validation in a way that a lot of modern programmers like to do it. Okay. So let's start with the first task there. And I think I'm just going to come right up here, up to the top. I'm going to indent a level, and we want to create a list of products, right? And I want you to think about how I just said that, right? So we're going to build a list that's going to hold the data type of product and all of its subclasses too. Like whatever I create, I'm going to be able to put into that list, right? I'm going to instantiate products as I'm putting them in, and then they'll be in there as kind of our little mini database per se, right? So here, I'm going to begin by just creating a list. We'll use the angle brackets, and then the data type I'm going to put in here is product. It's suggesting, it's not a bad suggestion. Thank you very much, Visual Studio. So I'm going to accept it, but I'm going to change the name here. I don't want to call it products. I want to call it salsas, right? Because that's what I'm going to put in there, a list of salsas. So this creates the list, and now it's ready to populate with items. And you can do this a few different ways, right? So what are ways that we can add stuff to lists? You guys remember? Right. Well, I have to go back to that PowerPoint and look it up is the answer, right? So one way you can do it is you can actually add, so if I said like, for example, salsas, add, I think it's add item or something like that. And I can just like start adding the items in. All right, use the capital S. I didn't want that. Salsas. Isn't that interesting why it's like grabbing? There we go. And then we can do add, and then you can do a new product, right? Or a new salsa right? And what I'm going to be doing is new salsas, by the way. So I could do it manually like this. I could just come in here and add those one at a time. Now I find it really curious, like, and nobody like questioned me on this at all, but why should I put product here? Is that the right data type? Dakota's nodding his head, yes. You seem pretty certain about it.
Yeah, because isn't product the would that be the master class
The
or
super
the
class,
super class? Okay.
right? And here's a trick. We can use product or we can use salsa. So like for example, if I do salsa here instead, obviously then I'm gonna have to fix this. I can also do this. And when I do my add then, right, I can then add a salsa product. So this is kind of weird, right? That you can kind of choose either approach and technically it will work. Now, what's kind of interesting about this, right? And why I might suggest that you switch it to salsa. Product kind of makes syntactically or semantically is a better word, makes more sense. I have a list of product and their salsas, right? So the way that that reads makes a lot of sense. But in truth, I can put inside of that list kind of anything I want as long as it has the same kind of complex data structure. And because salsas are subclasses, I can do it that way. But let's do a little experiment, in fact, and see if it really matters. What I'm going to do initially is because I like the semantic nature of doing it this way. I'm going to stick with this. And then if we run into any issues, we'll know what to fix. Right. So that's one thing I just want to put it on your radar. But notice list of product salsas. Yeah, kind of reads nicely. Right. So I could do this add method and start adding salsas. But another way that you can approach this is, and I don't know if you guys remember this, but instead of just putting a semicolon here, right, what I can do is I can put in, and then suggesting it right there, basically curly brackets like this, and then I can start introducing new products. But notice it wants to do a new product and not a new salsa because this is kind of like the default data type. But could I do a new salsa? Yes, I can do a new salsa. And then inside these parentheses here, I would put all the parameters in that would create the salsa, right? And this is a superfluous curly bracket. So for example, right? So if I call the salsa constructor, and I'm gonna have you guys think about this now as I'm doing it. If I call the salsa constructor, that expects 5 parameters. So I can give it all the parameters for the product right here. If I want to add another product, okay, so I'm noticing an error here, so I'm going to fix this right away because this is how my brain works. Red underline, fix immediately, right? So got to put a semicolon there. Right? Now, if I want to add another new product, I put a comma here and then just repeat the pattern. And yeah, I have a bunch of them already built. So I'm going to do this. And then you guys can come up with whatever names, titles, prices, heat levels you want. And I'm just going to hang here for a second while you guys are typing. But it's interesting though, and as you guys are doing that, I'm going to go ahead and change this data type again here. Ooh, it didn't like that, did it? That's because that's broken, but it's okay with it. Why do both of them work is really kind of the master question here. Right. And it really kind of goes back to this abstract class thing. because it's pretty flexible actually in what objects it takes in. Really, what we're saying here is we're creating a list of objects. It kind of doesn't really matter what kind they are, but you know, it'll run either way. I'll tell you what, I'll just leave it like this for now. All right. If you guys are hurriedly typing, I could give you, so here's one of those situations where generative AI is kind of acceptable. Like I could go to a generative AI and say, "Hey, I'm creating a list of salsa objects where these are the parameters. Can you please generate 50 entries for me?" you know, and let the AI create it for you and just paste it in. That's I would call that synthetic data, but this is synthetic data anyhow, right? So that's kind of one of those clever things. So you have my permission if you want to generate a list of salsas to go use a generative AI, but please don't have it write all your code. All right. Next thing that we want to do here is we want to think about a couple different aspects of like how we're going to process the next step. So I'm going to look at that list of instructions. So we got this one done. Now we want to put a menu up on the screen and allow the user to view the product data. Now, when I think about, okay, well, we're going to put a menu on the screen, what might make a lot of sense, and this is just how my brain thinks, is why don't I write a function to do that, right? Because if the user's always going to go back to the menu to make their choices, it's going to happen more than once, and I don't want to rewrite the menu every time or have it hard coded in a loop. Why not just write a function that does it? So that's what I'm going to do. I'm going to actually come down here and I'm going to make sure I'm at the right code level. I still want to be, well, I don't want to be inside the main method. I want to be just outside of it. So I'm following this dotted line down. And so I'm going to build my function down here. And I'm going to make this a private. This is only going to work internally. It'll be static. We're not going to be changing anything about it. It's not going to return anything. It's just going to put text on the screen. And I'm going to call it print menu. And then we'll do that, right? And then, curly brackets. And then it's printing a menu of what? Well, I'm going to take the list, right, of salsas or salsa, right, called, well, whatever you want to call it, salsa, or maybe here we call it products. That would work. List of salsa products. Okay, that works, right? So we're going to take that whole list with all the products and feed it in here. And then we're just going to make this loop through and write the stuff on the screen, right? But while it's writing it to the screen, we're also going to make it do a title, right? Little ASCII art there, and then a numbered list listing all the products and a prompt. Okay, so that's what's going to be inside this function. So where I start with mine is I do this. So I just do a console write line, right? I put dashed lines above, carriage return. I say salsa menu and dashed lines below. And then I want you to notice 0 to exit. Okay, why did I put that at the top? Because the example has that at the top. It's kind of weird, but there it is. Usually I think of the exit option being at the bottom, but it's number 0. Okay, put it at the top. All right, so I got that part all set. Then we want to loop through the contents in the salsa products list, right? So I'm going to say for int equals I equals 0. Okay, that's good. And then it's suggesting while I is less than the product's count, increment I each time. I like that too, right? I am going to close my curly bracket right away though, so I don't forget to do it because I have a habit of doing that if I don't. And then we're going to output the product. So in some ways, I kind of like what they're doing here, but I'm going to change the stuff inside here. So let's just get rid of that. All right. So their output in the example looks like this: a 1, a colon, a space, the name of the product. So the product name. So the property we're extracting is the name from whatever product is on the list. So I'm going to write that first. And the way that I'm going to do that is, okay, curly's, and then inside here, I'm going to say products, square bracket I, like whatever current position we're in the list, dot name. So we're going to pull the name property, and that's going to pull it back and put it on the screen. I have superfluous spaces in here. You can get rid of those if you want. So that'll put that on the screen. And I do need, okay, so I'm doing string interpolation here, and I'm not even doing it correctly. So $, double quotes, put this double quote at the end. So it works. Oops. All right. We'll just type it, I guess. I lost it in my copy paste buffer there. So there's the product name. But now we need the first part of the string. I is going to start out at the number 0, but we want it to print the number 1 for the first product. So in curly brackets, we're going to say I plus 1. Oops, plus 1. And then I think there's a period after it and a space, right? Colon after it, not a period. So colon, a space, and then the product name. So that'll loop through each product in the list, one at a time, extract its name property, put the number, the correct number in front of it, and a colon. Right. And then at the bottom, like after it puts all the products on the screen, we want to just basically do a prompt. So we'll do a console, not write line, but write. And we'll say, and I'm going to do a \n on that. I'm going to move it down a line, and then I'm going to say, choose a product. I think that's all right. Right. And of course, once again, I forget my double quotes. So here I am double typing double quotes and a semicolon. And then wherever we call this from, so we'll call print menu, it'll put this on the screen. The prompt is on the screen. So the next line in the main program body would be to capture the input from the user. Right? Right. So, all right. Now we have the function written. Now all we have to do is call it. So I can just kind of even forget that it's there. So I'm going to come back up here, and now I'm inside the main method again, and I'm right below my list of salsas. Now, okay, if your brain is saying, could I have taken this list and could I have put it up here on the global level? Yeah, sure. If you want to, you can do that. Yeah, I'm just saying it out loud right now, just in case your brain is wondering. Then the other thing I want to do here is I'm going to set up a loop, and I'm going to do this kind of in a weird way. And I don't know if we've done this much in this class, but I'm going to take a while loop and force it to run, right? I'm just true. While true, this loop will run. So how long will this run? Forever, right? Until really the answer is until the user chooses to exit. What I'm going to do at this point is, so the program starts, it loads up all the data, and then it's going to put the menu on the screen. So I'm going to call the print menu method, right? And yeah, I want to send my salsa list into it, right? So that's going to put the menu on the screen, right? All right. Then I want to capture input from the user, and I can do this a few different ways. And because the loop's going to run over and over again, I don't want to declare the input variable inside the loop. So I'm just going to come up here and right in this spot here, I'm going to create an integer called input, and I'm going to preset it to -1, and I'll explain why in a little bit. Right. Now print the menu. We have the menu puts up the prompt, and now I want to capture the input. So I'm going to say input equals, right? And it's coming in from the console. So it's going to come in as text, but we want it to convert it to an int. And so we're going to do our standard convert to int 32 console read line, right? So we're going to do this. Right, just in case you forgot how to do it from the, from all the other stuff we've been talking about. Right, so we're capturing that. And at this point, we're not doing any validation on it. We're just taking whatever they type and turning it into a number and storing it. And then later I'll show you the validation approach. All right, so we captured the input. And then what I did last time, and I must have had a reason for this, is I did a console write line. And I think it's just to put a blank line on the screen. So in other words, right, chose it, blank line, then put the stuff on the screen. That's what I'm doing. Console write line, just like that. All right, now we want to do a, what is it we want to do right now? And I'm looking at my code going, why did I do that? Oh yeah, that's my validation step, which we're not at yet. So they're going to read, it's going to read the thing, and then what's the next step that needs to happen? We need to capture that selection, and then what happens with that selection? Well, they picked up a certain product. Now we want to put that certain product on the screen. That's what needs to happen next. So, all right, let's do this. I'm going to write an if statement. I'm going to push it down a little ways here, and I'm going to think about the logic it's going to take to put the right salsa input on the screen, right? So, for example, and here's where my brain was getting a little sucked, because I'm thinking, oh yeah, why the -1 thing? Okay, so here's the -1 thing. So you get the menu up on the screen, and this is the first item in the list. So what's its index position? 0, right? The first, so it's numbered 1 here. So the user is going to type 1 to see it, but we got to subtract 1 to get to it, right? And the way that I get to it is I just very simply, if I say salsas square brackets index number, and I put that in a write line statement, what's going to happen? This is where, like, you're lecturing, hopefully it's stuck a little bit. Well, okay, so I'm just gonna write one of those, and I'll show you what I mean. So I'm gonna write console write line salsas square bracket. Okay, and it's doing all this fancy stuff here, but I'm just gonna do a square bracket, right, like this. And if I put in, just hypothetically, let's say that I put in, it just does not want to let me click there. Very interesting. I put in the number 1, right? This is going to grab the second item on the list. And will this output it? Yeah, it will. Here's the why. Because we're picking one of the objects out of the list, the object's got a toString method built into it. So putting it in a console write line, just loading it, will trigger the toString method inside of salsa, right, which would return this to the screen populated with data. Now the trick for us is, in the main program, to make it output the one that we asked for, right? And so we got to take the number they typed in input, right, and then make sure, well, there's a couple different ways. We still want to make sure it's a valid input, even if we're not doing the validation step. And then what value do I put in here? So they type the number 1, and I say input -1. Right. So if they chose the number 1, I want the 1 in the 0 position. If you choose number 2, I want the one in the 1 position, right? So that's how we would get it to the screen. All right. So here's a little bit of code that you can throw in here, right? Because now we have to do a little bit of checking anyhow, right? So I'm going to write an if statement, and here's how I'm going to orchestrate this. I'm going to say if the input is greater than 0. All right, well, what happens if it's 0? You exit. That's what the menu option says. So I need to write a separate if statement for that. And here's what I do before I forget. I'll often come in here and just say, oops, wrong language. Don't forget to handle 0. Right. So because otherwise I will forget. Right? So I'm just going to put that there. Right. So if the input's greater than 0, right? And the input is less than or equal to salsas dot count. That's one way to check that it's valid, right? Because if I have like six salsas in the list, this should work to keep it from failing, right? In terms of like, all right, well, I'm not going to do the next step until that's done. So right now, what I'm going to do is I'm going to make this console write line part of that if statement. So if the number is greater than 0 and the input is less than or equal to the count of the salsas, it's a valid item. So put it on the screen. This command will work, right? And then there is an else to this. What's the else? Well, they gave you a number that was not in that range, basically. So it's not from like 1 to whatever the count is. It's beyond the count or a very wrong number. All right. So that's how we can make sure that at least it's on the list, right? Now, I do want to handle 0 though. So that's a concern. And so here's how I'll do that. I'll just say if the input is equivalent to 0, what happens? If the input's equivalent to 0. Well, yeah, thank you, Visual Studio. That choice is to quit the program. So I can put in a break command there and you're out. But I also want to probably be polite and do something like this. Okay, I'm closing the application and then break. And I'm going to get rid of that. All right, but interestingly, why do I put in a -1 here? And I want you to think about one of the reasons for this. And this has to do with validation ultimately. But if they put in a number that's 0, it'll exit. If they put in a number from 0 to whatever the product list count is, that'll show the product. Or if it's too big of a number, it'll say invalid entry. But if they don't type anything, this will be set to -1. And then what happens? It'll just say invalid entry. Kind of interesting, right? Because that might happen. People might not type anything, right? All right. Another thing that you can do, and I find that this is kind of an interesting approach, and I'm going to show you this because this while loop is basically run the whole program, right? When you get to the point where they ask for a product and it comes up on the screen, this message comes up that says press any key to continue, and it just sits there and waits until you press a key. How the heck do you do that? All right, well, that's really actually pretty simple. And here's an approach, right? So down here at the bottom of the loop, mind you, the product's up on the screen or the error message is on the screen at this point. I put up a message, press any key to continue, and then I just put in a read line statement. It's just waiting for you to press a key. I'm not capturing it to do anything, but it absorbs the key press. any key you type in will get absorbed. Now, one thought, right, is I could also take this approach, put it here, like, so when they're choosing the quit, closing application, press any key to continue, let them press a key, and then they control the exit. So like when I ran that executable file before and it just launched and went away immediately, I could stop that from happening with a command like this in any console program, by the way. It'll keep it on the screen. All right. Question. Anything else I need to do here to make this program run? No, we're good. This is enough to make it run, folks. So let's give it a shot. Let's see what happens. So I'm gonna, assuming you guys have a list of salsas, right? You have all this stuff built in, right? Exit when the user chooses to. Okay, we're gonna still do this step. We're gonna do a different form of validation in just a little bit, and I'll show that to you. But we're gonna make this run as it is just to prove that it works. So here comes the run, or hope that it works, right? Is maybe a better phrase sometimes. All right, so there's my salsa menu. Let's zoom in on it a little bit. All right. All right, let's do 0 to exit. Okay, that worked. One thing I noticed that says press any key to continue. I pressed the space bar and it typed a space, and then I pressed enter to make it end. Interesting. So read line expects what? That you press the enter key. All right, let's run it again. This time, let's get a product up on the screen, or 5. All right, and I'm going to put in the number 1. I'm going to put in number 2. Pressing the space bar, pressing a letter key. So it's not really any key to continue. You guys picking up on that? You want to do a little challenge? Somebody Google, how do you press any key to continue in C# and see what command you're supposed to use. Because we're using read line, right? So that's why the enter command is there. So I'll let you guys figure out how to do an any key. All right, so let's do product number 3. Let's do product number 4. Let's do product number 5. Let's try product number 6. What happened there? Yeah, I think my if statement didn't work is how I'm reading it. So I'm going to type in a 0. So there's something of a little problem with this logic here, right? Because this else statement did not catch, right? So if I type 6, what it should have done is give me this. So is my logic right here? What would be the count of this list? 1, 2, 3, 4, 5. Index positions 0, 1, 2, 3, 4. But my count is 5. As long as I typed 5 and that worked. I typed 6. What is it? What is the condition that's happening? Input's greater than 0, and the input is less than or equal to the count. Okay, well, that didn't work. So, this didn't catch as true. So else should have happened. So I should have saw that message on the screen, correct? Yeah, I should have seen that message on the screen. So I'm not really sure quite what happened to it. But I am also going to put a new line in here as well. and maybe put a new line after. Let's save that code. Let's try to run that one more time. Now I'm curious about that problem. All right, let's type 5. Let's type 6. Okay. So I'm not sure why that didn't get you before. I think that's pretty interesting. All right. And let's try a -1. Okay. And let's do a 0 to exit. Okay. So far, so good. All right. Why don't we do this? I have the wrinkle to throw in about the validation, but we've been going for quite a while here. Let's take a break. Let's a good 5 minutes or so. And in fact, let's make it a 7-minute break. We'll come back at 8:20, and then we'll throw in the other validation piece. All right, back from the break now, and we are kind of dealing with a few issues here, but we're going to ramp up the validation here as kind of our grand goal. But to address that issue of like having to press enter where it says press any key, but that's not really what it does. What I did is I went ahead and I removed the read line command, because truly it shouldn't say any key, it should say press enter to continue. And I kind of notate that here, right? So I converted the above to a write line, right? So that handles its own key press in a sense, right? So it's not waiting for the enter to finish that line. And then I use a different command called read key, and that'll actually work for any key. But here's the thing, if I leave the parentheses empty, the key that you press, whatever it is, will write to the screen. That's not going to look good, right? So we throw in the true thing, and what that does is it eliminates that key press from displaying on the screen, because otherwise it would display on the screen. And so I'm going to run this, and I put this both in the any key to continue area, and I put it in the quit, and I'll just run it here and show you that it works. All right, once again, we'll zoom a little bit. All right, so I'll type in 1, any key to continue. There you go. I'll type in the 0, any key to continue, and I'm just kind of randomly pressing any key. And the first time I pressed the letter T, and the second time I pressed the tab button, and that worked too. But so now really truly any key is working. So that's a little hack there for you guys. All right, let's address this validation issue. And where I'm going to deal with it initially is right here up on this input statement. And so I'm going to comment that one out, and then I'm going to put in an alt, and I'm going to make a comment here, alt approach to validate better. So we kind of have validation in there right now if you think about this, but this will make it work a little bit better. And we did use this technique once before, and I don't know if you guys recall it, and I think I just did it so quickly that probably evaded your memory at this point. But what I'm going to do is I'm going to create a Boolean variable called valid. And all right, so it wants me to preset it to a value, but really what I want it to do is I want it to grab from the keyboard whatever the user types. We'll use the try parse method to see if it's valid for the data type that we want, which is an integer. So I'm typing that in right now, and then I'm going to try parse, set of parentheses, and then this takes a couple of parameters. The one parameter is, well, what is it we're reading in from the command line, right? So we're going to type in console.readline like that. So that's the first parameter. It's going to take that in. And then if it's valid, so this is what try parse does, it's going to output, sorry about all that, those pop-ups there, to the input that we grabbed, basically, that value. So that is going to output that. So let's say I type the number 1, and it's going to put it in that variable I have right there called input. And more importantly, it's going to set this Boolean here to true. If it's not the right data type, it's not going to output to input, and this will be set to false. So now I can check on that false on whether or not the input is good. See the different approach? Yeah, it's kind of an interesting approach. So I'm going to modify a few lines, and what I'm going to type here, so for exiting, I'm going to say if valid. So if it's valid and true, right, I would get a true here. If it's not, I get a false. And the input happens to be 0, then I'll exit. Because what if they type Z? Right? Yeah. What if they type Z? All right. So if it's valid and it's a 0, you're out of here, right? With the read key thing. Then down here, we'll also alter this if statement. And so I'm going to rewrite that. And with this one, I'm going to use the same basic syntax. I'm going to say if valid and, you know what, and all the stuff I did before. So I'm just going to copy all of this and put that right here. If it's valid and the input's greater than 0 and the input is less than or equal to the cells count, then it will proceed and and print the right thing. If it's not, so it's not valid, this is where we'll throw invalid entry on the screen. So this else actually handles this one as well. See the thinking? All right. That's it. That's the validation piece. Not very hard. Really, the trick to it is this try parse statement. This is a really powerful one. So what it does, right? So whatever we're doing, we're looking for this data type, right? Try parse reads something in. Where are we reading it in from? It could be from anywhere. This comes from the keyboard. And if it parses and matches that data type, it will output to this variable, which I declared up here, right? And store it. And it also flips this valid flag to true or false, right? Well, if it's valid, it'll say true, right? And then we can use that to drive if statements. So this is a little bit better validation. And now I think, if I'm not mistaken, we can also type in letters and not have it break. And that's kind of one of the advantages of this approach. So let's try that. Letter A. Right? That's better than crashing the program, don't you agree? That's why the try parse is a really good one. All right. So let's put in some of these. Let's just, test a few things. Let's put in numbers that are too big, right? Let's exit. And I think we have a complete working application here, folks. Right. So not too bad for the lab, right? A little bit of work, a lot of concepts though, because when you're like learning about all these classes and the abstracts and all those pieces, they don't often resonate. Could we have done this without an abstract class? Absolutely. But we did use the syntax. Like one thing that you could do, for example, is you could, if you wanted to really test this, you could write code that would just instantiate a product without the heat level, right? So instead of a list of salsas, I could have a list of t-shirts, right? And then we could make a different class structure here that would inherit from product, but it would be t-shirts. And I'm not sure what additional thing that we would put on t-shirts, but maybe like long sleeve or short sleeve. 100% cotton or not, concert t-shirt or, Hanes basic, that kind of thing. And so that you could easily ramp up this application to do many different things, but you could have any kind of product you want. And the point of it is that this is kind of generic for all products. This is specific to salsas, right? And then if I wanted a different product, I could create a different subclass for that kind of product, make a different list out of it, and then drive the application in a whole different fashion, right? But that's the completed lab, folks. So I'm going to end the video here.